Questions 11 through 20 on the 2010 Grade 8 AMC 8. The top of one tree is 16 feet higher than the top of another tree. The heights of the two trees are in the ratio 3 to 4. In feet, how tall is the taller tree? See here, one tree here, and then you have another tree here, approximately. And here's the ground that they both sit on. And this tree here is x, and this is x plus 16. And they tell us that the ratio of x over x plus 16 is 3 over 4. So this is the equation we have to solve. 4x is therefore equal to 3x plus 48, and therefore x is 48. But they don't want x, they want the height of the taller tree. So the taller tree is this guy, which is x plus 16, which is 48 plus 16, and that's 64. So number 11, the answer is B. Of the 500 balls in a large bag, 80% are red and the rest are blue. How many of the red balls must be removed from the bag so that 75% of the remaining balls are red? So initially of the 500, 80% are red. So that means 0.8 times 500 are red, and that is 400. So 400 are red. And of course the remaining, we don't even have to do the math. The remaining must be blue. Now they're saying that you're going to take out some from the 500, and then the ratio will be 75%. So I don't know how many we're going to take out, but let's just say that's x. That is what we have to do. So we are taking out red balls only. So from this 400, we have to take out a certain amount. So from 400, you take out x, and then you divide by the total, which would be 500 minus x. And that has got to be equal to 75%, which is 3 over 4. So if you do the cross multiplication, you get 1,500 minus 3x is equal to 1,600 minus 4x. And therefore, let's see here, 100 would be equal to x. And that's it. So number 12, the answer is D. The length of the sides of a triangle measured in inches are 3 consecutive integers. The length of the shortest side is 30% of the perimeter. What is the length of the longest side? So x plus 1, and x plus 2 are the lengths of the triangle. Now the perimeter, of course, you add these guys up. So x plus 1 plus x plus 2. And that is 3x plus 3. And then they were saying the length of the shortest side is 30% of the perimeter. So that means that x, which is obviously the shortest side, is 0.3 times this perimeter, which is 3x plus 3. And let's solve this math equation, algebra. So we got x is equal to 0.9 x plus 0.9, and that means 0.1x is equal to 0.9, and therefore x is equal to 9. So this is 9, this is 10, and this is 11. So the length of the longest side is 11. So number 13, the answer is E. What is the sum of the prime factors of 2010? Prime factors of 2010, 2 times 3 times 5 times 67. 67 is a prime number. So now we have to add them up because they want the sum of those prime factors. And that looks like it is 77. So number 14, the answer is C. A jar contains 5 different colors of gumdrops. 30% are blue, 20% are brown, 15% are red, 10% are yellow, and the other 30 gumdrops are green. If half of the blue gumdrops are replaced by brown gumdrops, how many of the gumdrops will be brown? Oh boy. All right, so here we go. Percent and number. So the percent of, we got, what are the colors here? Blue, brown, red, yellow, and green. Okay, so the percentages they give us, 30, 20, 15, 10. Green, they don't give a percentage, they give a number. All right. Oh, but I can figure out the percentage because I can just subtract all of these guys from 100. So 100 minus 50 minus 25, so 25%. Okay. So 25% represents 30 in terms of a number. So that means that 100% of all the gumdrops would represent 120, right? 4 times. And similarly, we can figure out the numbers for each of these. 10% would be 12, right? 10% of 120. 30% would represent 36, 20% would represent 24, and 15% would represent 18, as in terms of numbers. Now what they're doing is what are they doing? Half of the blue gumdrops, so half of these guys, so 36 divided by a half, so 18 of them, are replaced by brown gumdrops, okay? So I guess 18 will now become brown, and the other 18 remain blue. How many of the gumdrops will be brown? Okay, so now we have 24 plus an additional 18. So 24 plus 18 equals the total number of brown gumdrops now after this replacement. So what's that? 42? Yeah. So number 15, the answer is C. A square and circle have the same area. What is the ratio of the side length of the square to the radius of the circle? You got a square, you got a circle, and they've got the same area. Okay, no problem. So I'll just call this S, and the radius here we'll just call R. So that means that S squared is equal to pi R squared, right? Area of the square is equal to the area of the circle. And they want you to figure out the ratio of the side length to the radius of the circle. So find this. Well, using this formula, we can just put S squared and then R squared below it. And if you take the square of both sides, you get S over R is equal to square root of pi. And that's it. So number 16, the answer is B. The diagram shows an octagon, 8 sides, consisting of 10 unit squares. The portion below PQ is a unit square and a triangle with base 5. If PQ bisects the area of the octagon, what is the ratio XQ over QI? So XQ over QY. All right, well, QY I'll just call B, and XQ I'll just call A. And since they make up the side of one of those unit squares, A plus B is equal to 1. Now let's look at this diagram. They're telling me that this line bisects the area, so this area equals the other area, which is this area right here. Okay? All right, so let's figure this out. This area is just a triangle plus the unit square. They actually tell you that in the question. So it's 1/2 base times height. The base is 5, and the height is 1 plus b. And then, of course, we got to add that unit square. Don't forget about that guy. And that is equal to the area of this guy. But that's a weird shape. So I'm going to extend it like this. So if I do that, it's basically a rectangle, this whole thing, right? Which is 2 times 5. But I've got to subtract that I added, right? I can't just add it. I have to subtract it. But this represents just this shape right here. I've got to subtract from this triangle right here. And that triangle is, of course, 1/2 base times height, which is 1 plus b. And that's it. This will allow me These guys, if you put them on one side, it just becomes 5 times 1 plus b. And then all the numbers, put it on one side. This is going to be 9 minus 1, which is 8. And then, let's see here. Sorry, 10 minus 1, which is 9. And then if you bring the 1 and subtract that, it'll be 8. Okay, so there we go. So expanding, you get 5 plus 5b is equal to 8. And then 5b is therefore equal to 3. And then b is equal to 3 over 5. And then a plus b was 1, so therefore a is 2 over 5. And then now we can find the ratio of xq over qy, which is a over b, which is 2 over 5 over 3 over 5, and that is just 2 over 3. So number 17, the answer is D. A decorative window is made up of a rectangle with semicircles on either end. The ratio of AD to AB is 3 to 2, and AB is 30 inches. What is the ratio of the area of the rectangle to the combined areas of the semicircle? So they want you to find the area of the rectangle, the combined areas of the semicircle, so that'd just be one circle. All right. So let's see here. AB is 30. Okay, and then AB and AD, they've given us a ratio of 3 to 2. So I can quickly figure out AD. It's going to be 3 over 2 times AB, which is 30. So that means that's 45. So this is 45 right here. So the area of the rectangle is going to be 45 times 30. And then the area of the circle is going to be pi r squared. But r is half of 30 since 30 is the diameter. So r is 15. All right, so this, if you break this up, you don't even need to expand it because this will factor pretty quickly here. The 45 divided by 15 is 3. 30 divided by 15 is 2. And then you got that pi. So this is just 6 over pi. So number 18, the answer is C. Two circles pictured have a same center C. Chord AD is tangent to the inner circle at B. AC is 10 and chord AD has length 16. What is the area between the two circles? AC, they tell me, is 10, so this distance is 10. And then let's see here, AD, they tell me is 16, so half of that will be 8. And this is a right angle, so very quickly you can use Pythagoras to figure out what is CB. So CB squared will be 100 minus 64. So CB squared is 36, and therefore CB is equal to 6. So now the area between the circles is pi big R squared minus pi small r squared. Pi big R squared is 10 squared. Small r is 6. So this is 100 pi minus 36 pi, and therefore that is 64 pi. So number 19, the answer is C. In a room, 2/5 of all people are wearing gloves, 3/4 are wearing hats. What is the minimum number of people in the room wearing both a hat and gloves? Well, the fractions are interesting, right? You got 2 over 5 that are wearing gloves, and 3 over 4 are wearing hats. Now, these are people, so these have to be integers. So we've got to choose in the common sort of number that both 4 and 5 can factor into. And the least common one, since we want the minimum, is 5 times 4, which is 20. And if that is the case, then these numbers become 8 and 15. And now we want to figure out what is the intersection point. So, for example, I'll call this circle the glove circle, and I'll call this the hat circle. And we'll label this A, B, and C. Well, A plus B is the glove circle, so that equals 8. 8 people wearing gloves. And then B plus C, that's the hat circle, that equals 15. And what we're interested in is finding B, because B represents people who are wearing both glove and hat. We also know that A plus B plus C, all of the people, is equal to 20. Okay? So we have to solve this. No problem. From the first one, if I substitute A plus B is equal to 8 right there, this becomes 8 plus C is 20, and therefore C is 12. In the same equation, if I substitute B plus C is 15, it becomes A plus 15 is 20, so therefore A is equal to 5. And then put those two numbers back into here. You get 5 plus B plus 12 is equal to 20, and therefore B is equal to 3. So number 20, the answer is A.